This conference will now be recorded.
So now we'll start with module 4. So where we are discussing about analytics using PIG. So once we done with the conceptual thing and then we go with the hands-on part also.
Yeah.
Right. So this will be covered later as discussed.
Yeah.
App reduce part. Right. Fine.
Yeah.
Now this is our agenda. Like first of all, we'll understand the issues with MapReduce programming, right? And we try to get some introduction to a PIG also. Then here we are having a language called PIG Latin. Okay, it's a very simple English type language to understand and to process the data sets. So we'll try to do some comparison Apache Pig language with MR also. Nothing but the Pig Latin with MR when you're trying to do some processing. How it how MapReduce behaves and how this particular Pig Latin behaves. We'll understand that. And where to use Pig and where not to use Pig because Pig is all having some limitations. So you can't use Pig for all the data sets like when you're having some you know complete unstructured data like if you're having some video streams or audio streams pig is not you know a good tool to process. It can't process any data like that. And we'll understand some use cases also of pig. And after that, before going to the programming, we had to just understand the programming structure also, how exactly the pig program structure looks like, what are the main parts it have really. And once we understood that, then we can start the hands-on part. Like we'll be working on the relational operators, data models, and diagnostic operators. And the pig is having some inbuilt join functionality. Apart from the normal joins, is having some replicated and skewed and merge joins also. So we'll see that. And it's having some user-defined functions also. So whenever just missed out a built-in functionality, or if you missed out the primitive functionality, so then you can go with the user-defined functions. So once again, in this path, you need some Java knowledge to understand, to implement the user-defined functionalities. Then after that, code reusability concept is also available in Pig. So that can be achieved via macros concept. So instead of writing everything from the scratch, once you implemented some business logic for a certain requirement, same I can use in my business logic also by calling the particular macro. So we'll understand how it can possible. So finally, the XML parsing. So whenever you're having some semi-structured data like JSON or XML, straight away we cannot understand that. I will show you, of course, I have not included the JSON path here, but I'll show you a simple example or scenario on JSON also. So whenever you're having some semi-structured data like XML or JSON, it's really tough job to process with big because we cannot understand. For example, you're talking about XML, it will have some tags and in between you having some fields and values kind of thing, right? So we need to extract the values initially. So how to extract that, how to bypass those particular tags. So the answer comes from you know regular expressions or XPath, what we call generally, right? In XML we are having certain tags and all, and in between you are having some values. So to read that we need to extract those values initially. So for that we'll be using certain mechanism. Okay, we call XPath or regular expressions mechanism. So both the things I'll show you, and after that I'll take JSON data also, and I'll show you how to parse the JSON data. So we are not processing anything, that just we are parsing, nothing but we are trying to read the data set. We are extracting the elements from the given XML or JSON. So once the data is available, then you start working on them. Okay, how you want to process. Okay, just store it HDFS, or you can use any high tables for that, or you can do the processing activity using pig once again. So processing is different, and just here trying to understand the parsing activity, nothing but how to read that data first of all. because PIG is right away not able to read the data. We can read only data if you're having in a comma separated or tab separated like the way CSVs and TSVs, what we call in general. But if you're having some semi-structured data, right, like JSONs and this XML, so initially we need to go with some certain mechanism so that we need to extract those elements. So once the data is ready, now okay, once again you can start processing the data. So that's what, this is our hands-on part. Now we'll start with this conceptual thing here. So coming to this, we are saying a MapReduce is very powerful. So very powerful in the sense, what sense we are saying it's very powerful? It's application. See, when the power of this MapReduce is really like whenever you're having a structured data or semi-structured data or unstructured data, any kind of data that you can take, okay, from a normal text data to, you can have some audio data or video data, anything you can take, and or maybe you're receiving some sensors data, IoT sensors are sending some data, and from which you want to do some maximum minimum compression, right? So or you want to do some cryptography functionality like encrypting and decrypting the data. So anything you can talk about that is possible via MapReduce. But problem with this MapReduce is, it certainly requires a Java programmer, because the API is matches with this particular Java programming. So you should have some good knowledge in in Java. Then only you can write programming here, right? So suppose you are a Java guy, then there is no problem. You can understand the MapReduce flow, and you'll be taking some time to improvise your business logic, right? And you can debug that code. And whenever I changed my business logic, nothing but I changed my requirement. So you're having some IoT sensors data. Earlier you're finding some maximum and minimum temperature. Now I said, no, Naresh, just you want to find out the maximum rainfall and the minimum rainfall or some humidity. So what you need to do here really, all the way you need to change complete the business logic. So once again, you need to write a very big Java program. So what's difficulty level here really? So to process the data, even it's a small data or a big data, it doesn't mind. The business logic to improvise the business logic is a big task here, right? Why? Because we don't have any common functionality, or built-in functionality is not available. For example, if you want to join two tables, like you're having some student table and result table, and you want to join these two tables based on the student ID, and you want to announce the result, right? So this is a very simple task in SQL. But coming to Java, right, kind of programming, nothing but in MapReduce programming, you need to write a very big program for that, because straight away you cannot join or you cannot filter anything. So certainly this is really tough job. Okay, like the guys like data scientist and business analyst, so they need some abstraction. Okay, you can't insist them, or you can't ask them to write a very big Java programmers, and you just like teaching them the MapReduce concepts, and what is the block size, how the block level processing happens, what is the job tracker, task tracker. So certainly this is really clumsy for them. So that is the main issue here. See, for example, even though you're having a small data or big data, that is okay. Your KB, you're having a KB data, or gigabyte data or petabyte data, whatever it may be. But certainly what you need to do here, see, you need to write initially. First of all, you need to have IDE to write your business logic. So Eclipse, you can take any IDE, integrated development environment. So where you can write or start writing the code initially for mapper, then reducer, then driver. So this driver is nothing but the meta information, like how you are providing, what is your mapper name, reducer name, what is the input format and output format. Okay, so a lot of things we have to specify in the driver. Okay, so once you implement the business logic with your mapper and reducer, so here what you have to do, you have to write your own mapper, and it has to extend the parent mapper class, because we are having a parent mapper class and reducer class, so we need to extend the functionality to your child class, or what you call in Java is something like inheritance. So already you are having some base functions or parent functions and parent classes. So although you need to get the functionality, so for that you need to write a very big code, and after that you need to write the business logic. So very big task really. So initially you need to write the mapper logic and reducer logic and then driver logic. Then you have to create a jar file. For example, you want to keep a jar file name as abc, so just you need to create a abc.jar for a certain requirement. Maybe here, you know so we are getting data from this IoT sensors. Okay, so we're getting some data here. So initially just we're interested to find out the max and minimum temperature. So for that you just implemented the mapper logic, reducer logic and driver. Finally you created jar file. So once the jar file is available, we are running this jar file. So like this, Hadoop jar, and your jar file name is abc.jar, right? And the data set, maybe your data set name is okay, max.dat. This is your data set name maybe. So just you're giving these details here. Okay, max.dat output op, right? So this is how you're going to process the data. So creating a jar file with the help of the classes, nothing but with the help of mapper, register, driver. Finally you're able to process the data. So here this generally requires a lot of development time, isn't it? So because we just missed out the built-in functionality, so everything has to be written completely. You know, ultimately it demands huge development time here, right? And just I came here and just asked Naresh, no, I don't want to find out any maximum temperature with this given data. I want to find out the humidity level. Okay, instead of that, I want to find out the humidity level. So this jar will not works for you. Okay, this because you implemented based on this logic, right? Now your requirement changed, right? Now your requirement changed, and you want to find out the humidity level here. Then what you have to do? The story remains same here. Once again, you need to, okay, develop one more jar. You need to write the mapper logic, reducer, driver, and you need to create a jar file. For example, hum.jar, and you need to run the jar file here. This is a really cumbersome process for the guys who came from this data science and all. Got it? So that's the main issue. So by focusing on this, okay, Yahoo implemented a tool called Apache PIG. This is purely a scripting platform. Okay, so this is purely a scripting platform where you're processing the data very easily. We don't bother about the data size. Why you are not bothering about the data size? Because pig is not having any own storage area or own processing area. Please do understand, pig is just providing a scripting platform. You can write some script by using some pig latin statements, and you can able to process the data. Got it? So ultimately, once again, the storage is HDFS, nothing but Hadoop only, and the processing also MapReduce only. I'll tell you, don't get confused. Okay, so first of all, we'll understand what exactly this we can do. So it's a purely a scripting platform for processing and analyzing large data sets. So it's very easy thing, like it doesn't require any IDE. It doesn't demand any IDE like Eclipse and all. Just open a notepad and write your scripts. I mean to say, you write your big Latin statements and all one by one, and store that with an extension called .pig. That's it. Your script is over, and run that script. Okay. See here, for the same requirement, you need to, you need to find the maximum and minimum temperature and also we doesn't require any IDE here. Okay, it doesn't require any IDE here. So just open a notepad. Okay, and write your big Latin scripts or statements, I can say big Latin statements like 1, 2, 3, 4, and 5. That's it. Say with the dot extension with pig, something like our pig name is XYZ. Just say xyz.pig. That's it. Your script is finished. And even coding is also not required this much. So we don't have any concept of mapper, reducer, driver, and anything. So coding is also very simple. Okay. For example, here you are having some 300 lines of code that can be finished within just 10 to 15 lines. That's it. And running is also very simple. So once you are ready with your script, just open the terminal. Okay. And there you go directly. Like pig space xyz dot pig. This is as much simple as like this. That's it. Okay, right. So basically it's a scripting platform. That's it. And here I'm saying one more thing called it's a data flow system. So why I'm saying it's a data flow system, I'll explain in my coming slides. Right. Of course, roughly 30% of Hadoop jobs runs at our Yahoo or Hadoop. 30% of Hadoop jobs, which are running at Yahoo are the peak jobs. Now here you can see how Yahoo is heavily using this particular PIG. Okay, so what is the advantage with this? Smaller learning curve, so no need to be, it provides or it insulates the completes the Hadoop complexity. So you should not be aware of what you mean by mapper, reducer, driver, how to develop it, what do you mean by that IDE, how to create a jar file, what are the initial required packages or so classes and everything. So nothing is really required. At the same time, suppose maybe I'm using Hadoop generation 1 or Hadoop generation 2.2 version. Maybe the other guy is using 2.7. So like this, there is some difference with Hadoop versions and all. It doesn't give any impact on your PIC script. Okay, once you implemented your PIC script, it can work on any Hadoop version. So no need to change any business logic here. And it's providing an ad hoc way. Okay, so it providing a ad hoc way because we don't doesn't require any IDE and no need to create any jar, right? Just now I have shown you. Just to take a notepad, there you write your big Latin statements and save them with extension .py and run. That's it. So it's providing some rapid development here. Okay, it's certainly providing a rapid development here. Now it's a big Latin language, it's a very simple to understand. So whenever you're looking to process some data manipulation that you're looking, so you can go with pig. Look at the first line here. So your pig Latin statements are converted or compiled into MR jobs which are not Hadoop. So what you mean by that really here? We'll understand. Okay. So here what we are saying, our pig Latin statements are queries, whatever it may be. Those are going to compile to MapReduce jobs so that they can run fine on the Hadoop. Okay, I'll tell you what exactly that. See, these statements belongs to the generational kind of thing here. See, once you're, you just implemented some business logic, 1, 2, 3, 4, and 5, that's fine. You have to remember certain things here. So you're working on this data, right? You're working on some max.data. This is your problem statement. Okay, this is your problem statement I'm writing here. So you're receiving some data from IoT sensors and you need to find out the maximum minimum temperature. That's it. So if you want to process this data using PIG, where you want to keep this data? Because PIG is not having any storage. Okay, PIG is not having any storage. So ultimately this has to copied to HDFS only. Okay, got the idea here? So PIG is not having its own storage area. So that's the reason what you have to do. This data set has to copied, sorry, copied to HDFS. Because PIG is not having any storage area. Ultimately, whenever you want to process any data using PIG, the data has to be kept on your HDFS area, Hadoop distributed file system. Now, coming to the processing. Okay. So this is about storage, right? And what about processing? So you're having a script, right? Just you're writing PIG Latin statement one by one, 1, 2, 3, 4, 5, and finally you saved this as xyz.pig here. And you're running your script like this, right? So then what happens? This will be converted or compiled, I can say, into MR jobs. Okay, it will be converted into MapReduce jobs. Why? Because you know that whether you're using high or pig or whatever it may be, right? Whether you're giving high query language or pig Latin statements, that will be compiled or converted into MR jobs only. Because Hadoop knows only the things in MR, MapReduce only. So your big Latin statements really a Greek and Latin statements for your Hadoop processing engine, right? Hadoop processing engine does just only knows the things in terms of mapper and reducer. It's not having any idea about your high query language, or it's not having any idea of your big Latin language and everything. So what happens then? So if you're giving something like you're trying to run your big script, which is consist of some big Latin statements like this 1, 2, 3, 4, 5, like that way. So this has to be compiled into MR jobs. So finally you're going to get the output. So finally, what is the synopsis of this? So whenever you're looking to process some data, storage will be HDFS and processing will be once again with the help of MR processing engine only. Okay. So earlier, like you're creating mapper, reducer, driver, everything manually, and you're creating a jar file. Now what happens? Just you're writing a big Latin statements, and that will be compiled to MR jobs with the help of PIG engine here. Okay. So we don't need to worry about this. Your PIG engine will take the responsibility of this. Okay. So as a developer, no need to worry. You just write your PIG Latin statements. That's more than enough. The rest of things will be performed by whom? The map reduce. And I mean to say initially with the PIG engine, the statements will be compiled into MR jobs and will be running at the Hadoop cluster. Running on the Hadoop cluster. That's it. Got it? So whenever you want to process what you have to do, you have to copy the data initially to HDFS.
Yes.
After that, you just start writing the business logic for PIG, what statements and the problem statements. Then, while the moment you are running, your script like this. Your pig engine compile this into MR jobs, and finally you're going to get the output. That's it. Fine. Of course, pig Latin once again here the same point came. I'll tell you later. It's a data flow language. Why I'm calling it a data flow, I'll tell you later. Intentionally I kept the statement there, and of course it's a language which is intended to sit between the MapReduce and SQL, of course. Some because like SQL, like here we are having some primitive functions, or we can say built-in functions like join, sort, order by group. So a lot of built-in functionality is available. You can use that with the big Latin statements and all, by which you can do some standard relation transformations and all. And look at the next important point here. Schemas are optional and will be used whenever available and can be defined at runtime. A lot of important points here. So what is that? The schemas are really optional here. First of all, what is a schema here? Okay, we'll understand that. And here we are saying it's purely optional, right? So if it's all available, you can define them in the runtime. So big doesn't worry about any data types and the fields what you have not given it. Okay. So right. Generally what happens, I think you're having some idea on the SQL, right? So how you will keep your employee data in tables? Suppose you're having some, okay, forget about your employee data and all. You're having some products like 100, and this is okay, Nokia, and this is some 1,000 rupees. Okay, and product ID 101. This is my Samsung, and this is 2,000 rupees. Product 102. Okay, iPhone, and this is somewhere 3,000 rupees or dollars, whatever it may be. So first of all, if you're having certain data, right, and you want to store and process using SQL, so what you're going to do now? So first of all, we need to create a table, right? Maybe this is product ID, and this is the product name, and this is about your product price. If I'm giving like this, and after that, like okay, analysis and all, that's fine, but how are you going to load this initially? So if you want to analyze, of course you need to create a table first, and after that you need to load the data, then you can start processing, right? So these are the steps, right? You need to create a table first, insert or you can say load the data, and in the third step what you're doing is trying to start processing. So you're applying some business logic, that's it, based on your requirement, that's it. So maybe I'm not writing, of course, as per the syntax. So you're creating some table, right? Create table. Okay, some, what we can say, we're going to give some name, phone, and maybe you're writing this all the details, right? So this is maybe varchar, and you're mentioning the size also, and this is character data, and maybe this is a integer data, and along with the data types and the size also, varchar maybe of 20 or 30, whatever maybe you're giving here, right? Then you're writing what? See here, I'm not writing as per the syntax here. So then you're writing some statement called insert. So insert into, okay, phone, then you're writing something here. Okay, you're writing some product ID and the name. So maybe you're inserting this and you're inserting some price like this. You're inserting all the records, right? Of course, after that, maybe you're trying your queries to process this data, right? Maybe you're writing select star from phone. Oh, where, and you're giving some condition. Price is less than or equal to some 2000. Of course, this is your processing statement. That's fine. Now, before that, please let me know, can I create this table without this schema or not? Can I get a quick response?
No.
Right. Ultimately, what I had to do, you had to provide the field names along with the data types.
Yes.
What is the purpose of this? Because whenever you're trying to insert some records, this will be cross-verified against to this data. If it matches with this, then only you're able to insert the records, right? Because if it's having like, here you're having some P100 like this. Suppose in the salary field, you just specify that as an integer. So here I have to insert 1000 like this only. So I cannot insert this record as, something like maybe the other record. We'll take the other record, something like, product ID is something like this is, sorry, I have wrongly entered here. So P100, this is the product name, right? And this is about my P200, sorry, P101. And just I'm going with my Samsung. Now coming to here, I had to insert as numeric values only. I cannot give like this, right? Some 2000 like this. So this is not a valid thing because, okay, here I'm just not giving as per the schema, nothing but I'm violating the schema here. This should be integer, not like this. So that moment I'll be getting an error. Just verify your metadata, because as per the metadata you're not inserting the data. It should be integer value, not the character data. So right, so that's what exactly it's doing. So blindly it's not taking any data, so everything will be cross verified against your metadata. So that's what happening at your SQL level, right? So coming to this pig, what you're saying, look at this. This metadata is purely optional. So if and all is metadata is available, that's fine. So they're going to be used when available. If not, then there is no problem. Okay, you just provide them in the runtime, that's fine. If you don't have any idea of the metadata, so just forget about the metadata, and still pig is able to process the data. It won't stop you there. Okay, it won't stop you there. We're going to see that practically. Okay, so how without a metadata, how it can take and how it can process the data, we'll see that practically. I will show you. Okay, this is the interesting thing here, right? So big doesn't verify anything actually. Okay, it will it takes the data, but while processing, if any mismatch is there, of course that will be replaced with a null value. That is the first point. And the second important thing, even though you're not providing or giving any data types along with the field names, nothing but your metadata, default, it assigns the things into byte arrays. We'll see that. Okay, I don't want to discuss everything by showing the PPTs. So practically I will show you how it will take the data without the metadata also, right? So already we discussed 10 lines of your big lattice statements almost equals to 200 lines of Java approximately. Suppose you are taking 4 hours to write, okay, to complete this 200 lines of Java approximately. So within just 15 minutes, 10 to 15 minutes, you can complete the big lattice statements, right? That is really a good thing to hear. So here, the development time is very less here. Okay, the development time is very less because we are using some standard relation transformations whenever possible. So no need to write everything from the scratch here. That is a beauty. Fine. Now where you can use this big heavily. So whenever you want to process any clickstream data or weblog processing, okay, those are the best applications areas that we can say. Okay, so like generally Apache logs, even log files streaming. I mean to say clickstream data analysis. When you're talking about these are log processing, we are having different logs. Okay, combined format, compact format. Like you having different log formats also for everything. Like I mean to say for all the data types of log. Pig provides a beautiful solution with the help of the regular expressions. It's very simple. Okay, no need to worry about that. Even though you are getting log from the different file format. Okay, so even then Pig provides some regular expressions with the help of that, so you can easily process the data. Of course, that's fine. But what is the advantage of this weblog processing or clickstreams data analysis in real time? See, for example, there is a word called target audience, right? There is a buzzword called target audience and all. So what do you mean by the target audience really? See, for example, you be going for some shopping and all, right? That time, if you went to a particular shop first time, they will take all your details, like what is your occupation, your date of birth, your age, and whether you got married or not. If yes, how many kids that you are having. What is your financial status? How many cars you're having? And how many flats you're having? Right? Like they will take some information and they will give you use. I mean to say some card. Some unique card to you with a customer ID and all. They will give you some card. So they will insist you like whenever you're doing shopping with us, please use that card. Right? So then you'll be using that card. Maybe if you're purchasing something in online or offline, that doesn't matter. You'll be using your customer ID, right? Similarly, just you have created a ID in this particular, eBay or Amazon kind of thing, some web portals, e-commerce web portals. So they're also you starting your purchasing and everything, right? So what happens here, whenever we are trying to analyze the log of a particular customer ID, then we'll be getting some complete idea. I mean to say, yeah, the nature of the customer we can assess very clearly, right? So what kind of products he purchasing, how frequently he's buying the products, right? So like the way just I will try to analyze if you're doing some online or offline. Online means I will try to, figure out your IP address, your login time. Maybe every Saturday you're having some weekend, or maybe you're having some camp or week off at somewhere in Monday or Tuesday. So that time maybe you're interested to buy some online products and all. Maybe you're buying some smartphones or tablets regularly. So now once I got this information, right? What I can do, I can send some promotional, mails or text, whatever it may be to you, so that I can improvise my business here. Suppose you are more and more interested to purchase some new gadgets and all. So whenever a new gadget is added to my web portal, I'll be just targeting you. I'm sending some information to you, right? All the way I'll be announcing some combo offers also. And I'll be using the same information in the recommendation systems also. Suppose, you're trying to purchase a smartphone in the, you'll be getting some combo offers also. And I'll be giving some idea. The persons who bought this smartphone are also purchasing something like, some screen guard or, additional battery, okay, or some pouch or whatever it may be, some add-ons, some headphones, like the way I'm giving, right? So what I'm doing here really, I'm just enhancing my business by introducing more and more products based on your behavior. Okay, right? So this is what exactly you can do in terms of clickstream data analysis or log data analysis and all. So you'll be finding a lot of information. What is your IP address, a particular thing, and how many views that you made really, and frequently buying things. So a lot of things we'll be working on this. Okay, I'll show you that use case also. As an assignment, I'll just provide you, just give it a try, otherwise I'll explain. It's a good thing. It's a real-time experience that it will give you, right? So whenever your requirement matches certain things, Pig really does help you a lot, right? If you want to improvise the same thing in MapReduce, really takes days together because it's not having any regular expressions or XPath processing kind of procedures. It's not having everything. You had to write the business logic manually. It's the main thing here. And coming to the comparison to SQL to Pig, right? SQL is a declarative programming language, we know that. And coming to Pig, it's a data flow language once again. First, as of now, we have not discussed anything. I'll tell you later why I'm calling this. And he committed the SQL, schema is compulsory and it's a mandatory. Without schema, you can't insert any data. So coming to Pig, schema is purely optional. If and all have you're available the schema, just you can provide in the runtime. It's not mandatory. And SQL is good for the low latency queries, but Pig is really not meant for that. Pig is good for batch data processing. So here it's not allows you to know random reads and writes. Just give some terabyte of data and you just try to analyze the data. That's it. That's a more what you can do with Apache Pig. Not for simply select star from employee where location is equal to Bangalore. So this is not really meant for Pig. Okay. So you're trying to do a lot of analysis here, a lot of data insights that you perform. That's the main purpose of your Apache Pig here. So we'll see that later. I'll show you practical words an atom, tuples and the bags and everything. I'll show you. So here in this particular moment, I didn't want to discuss anything. So where to use Pig here really? So whenever you're looking for some time sensitive data loading and you're looking to process the data which is coming from different sources, or you want to work some sampling data and based on that you want to work more and more insights on actual data, that time also Big is a good choice for you, right? But whenever you're having more and more complete and structured data like videos or audios, or just you want to go with some reviews on the social bookmarking sites, nothing but the raw human readable text, that time Pig is ultimately not a good choice for you. And one more interesting thing here, Pig doesn't allow to you optimize your code. So there is no way to optimize your code. Okay, just you write your Pig Latin statements based on your logic. That's it. So you can't optimize anything. So what do you mean by that optimizing? See, generally, whenever you're working with any SQL kind of thing or any relational database management systems, you'll be having some query optimizers, right? Suppose you are having 10 queries with you, and maybe instead of running those queries in order 1 2 3 4 5 like the way, if you are working with if you are running the queries in a fashion 1 3 5 7 or 8 2 like the way, so you'll be getting some more optimization. You'll be processing your data more fastly and quickly. So generally we are having some query optimizers, right? It will give you some idea which statements to run first and which statement should be given next like the way. But unfortunately in Pig we don't have any query optimizers concept, right? You write your Pig lattice statements based on your requirement, and Pig will take care of how to run those statements. So it doesn't allow any optimization. It doesn't listen to you. Okay, it will go by its own way. That's the main problem here. Now Pig is definitely slow when compared with the MapReduce jobs. Why I'm saying when compared with the MapReduce jobs, it's pretty much slow here, because once you have given the pig Latin statements to your pig engine, internally pig has to do a lot of jobs here. Like it has to do logical plan, physical plan, and MR plan. All these plans has to become finally that it will be converted into MR jobs. Okay, so got it. So here itself we said, let me copy this particular line to here. So here I said, right, compiled into MR jobs. So what do you mean by this? So this is nothing but it has to do all this internally, right? Well, the moment you have given this p space xyz dot p, so it will do like logical plan, physical plan, and all the things. Finally, these jobs are going to compiled into MR jobs. So that's the reason what we can say here, the development time is less, but the execution time is more when compared with the MapReduce. Okay.
Yes.
Yes. For development, these 4 to 5 statements, ultimately you're not taking hours or days together. Within 10 to 15 minutes, you can write. But while execution, what need to happen? This has to convert it into or compiled into MR jobs by doing all these activities. Certainly, it will be a slow one. And one more thing here, whenever you're having some complex logic, like you want to encrypt the patient ID or the customer ID, or you want to decrypt. So this type of activity is certainly not possible straight away with Apache PIG. So you have to all the way go with the UDF functionality, where you are using some cryptographic algorithm like RSA or AES. Okay, we'll be using some cryptographic algorithms, and we are writing some encryption and decryption functions. So once you implemented those encryption and decryption, you can write or you can use the functionalities in your PIG script. But straight away you cannot say something is encrypt and something to decrypt. That is not at all possible. Okay, please do understand that. So complex logics, when you're not you want to run, that is not possible with PIG. So you have to depend on some Java functionality, nothing but the UDF functionality. So by using UDF, you need to create encryption and decryption. And once the functionality is provided, that can be used in your big Latin script. That's it. So coming to the ETL for unstructured data, whenever you're having some unstructured data which is generated from your log server, I mean to say logs are generated from web servers or application servers or click streams. So there is an ingestion tool called Flume. With the help of that, we are just ingesting to Hadoop. Once the data is reached to Hadoop, so for cleaning and aggregation, we'll be using Apache PIG. So this is the area. Okay. So overall, this activity just here in these two modules or steps, we are using Apache PIG. So PIG is not meant to stream some data. For streaming, you have to use a tool called Flume. Okay. So once you streamed the data to Hadoop, so for this cleaning or aggregation jobs, you'll be using Apache PIG. So finally, of course, based on your client requirement, you'll be taking that into data warehouse systems, or you're preparing a batch reports, or you just taking and dumping into any business intelligence system. That's a separate thing. Okay, you'll be using some reporting tools like Quickly or Tableau kind of thing, or you'll be taking the data to any data warehouse systems or batch report. That's fine. That is no concern, no way concerned with this particular peak. Peak is only working in these areas, cleanup and aggregation. So when you're talking about ETL jobs on unstructured data, and the ETL jobs on unstructured data, on structured data means suppose you'll be receiving data from Oracle or MySQL, whatever it may be. So there is a tool called Scoop by which you can do some import and export to Hadoop. See here also this Flume is connected with Hadoop, not with the pig here. Okay. So this data will be initially ingested with the help of Flume to Hadoop. So once the data is reached to Hadoop, you'll be working on this cleanup and aggregation procedures using your pig Latin scripts. That's it. So here also same thing. Suppose you are having some employee data or department data, whatever it may be, and you want to join those root tables with the help of PIG. So initially just bring those employee table and department table by connecting to Scoop to Hadoop so that your data will be available here. Now you just do starting the transformations and aggregations and everything. Then of course this remains same here. Okay, like you may be looking for some long-term storage or going with some data warehouse systems or business intelligence or batch reports. These are the next levels here. Clear?
Yes.
Fine. Okay, so what we'll do is we'll take a 5 minutes quick break, and after that we'll understand this use case and I'll explain the programming structure, and we'll be working on simple 2 or 3 examples. Is this fine?
Yes, sure, Anil.
Yeah, just will come back within 5 minutes.
Okay.
Hello.
Hi, Anil.
Yeah, shall we continue?
Yes.
Any queries?
Mm, no. This this will go. So this we can
Oh,
continue now.
okay, fine. Right. So coming to this, just we'll try to understand with a simple, data analysis task. Like I'm having two data sets here, like visits and pages. Two data sets I'm having. So one is having that user URL and time, and the other is having the pages. Okay, which is talking about the URL and the page tag. Suppose I just want to find out the users who visited some good pages. So based on like I can put some benchmark, like I can take the average page rank, and I can set a average page rank, and based on that I can just define whether a particular user visited a good page or a bad page. That's what I can do really. So for this particular statement, problem statement, and you just ready with the data sets and all, how you going to do, or how you going to process in Apache PIG? That's a good thing here to know. Okay, right. So coming to this, first of all, please do understand we'll be calling these are the data sets only, not the tables or something. Okay, we have to call these are the data sets only. So please don't call these are the tables and all. I'm having some visit table or pages table. It's not like that. This just will be calling as the data sets only, right? So I'll tell you the reason also why we'll be calling the data sets only. Because you'll be receiving from the client in a format called TSV or CSV most of the time, and you are not at all receiving any table format, nothing but a structured format, right? And they will supply the metadata if and all available separate file. Like for example, user URL time, these are the field headers, and they may have some data types and all that will be separated and kept under one more file, and they will be sending with that this particular data set. That's fine. Now to process this particular thing, like just what is our requirement, we need to find out the users who visited some good pages. So normally if you're having a same problem statement in SQL, how you going to do, just consider these two are tables, and if you're working on a SQL, then what you're doing, just you are joining these two with a you know the common thing. Maybe you'll be trying to tag with the URL, right? And you're trying to find out the page rank, and then finally you announcing the result. These are the users who visited some good pages and all. That's it. So coming to this peak, ultimately this is a basic peak program structure. So it will have something like load, process, finally store or dump. So three phases will be there when you're talking about the peak programming structure. It will be having three phases. First one is the loading, and second one is the processing, and finally you'll be having the store or dump here. So this processing also known as transformations function also. Okay, transformations phase also the process. Someone will call process and someone will call transfer. Ultimately, you need to understand whenever you want to process any data using pig, you need to undergo with the three phases: loading, processing, and finally store or dump. So what do you mean by that loading? So loading doesn't mean that you're loading some data from local file system to Hadoop for processing purpose. Okay, so load is simply a file handler. That's it. Okay, load is simply a file handler. Okay, so I will tell you what you mean by that file handler. Just you remember that word. That's it. Okay, in my next slide, I will show you an example and I will tell you what you mean by that file handling and all. Okay. So load here, what it will do really, it's just a file handler, that's it. Okay, right. So if and all if a schema is available, you'll be specifying in this load statement only. Okay, for a given data set. If it's not available, don't need to worry, just forget about your schema and all. Okay, now in the processing step or the transformations phase, what you are doing here, just we are giving all the big Latin statements like maybe order, join, group, sort. So it purely depends. Depending on your use case, you be giving all those transformations, or we can say some processing. Big Latin commands we are giving here. So finally, store or dump. So store means what happens and dump means what happens. No need to give both the statements. Either you have to give dump or store you have to give. So if you say dump, what happens? The result will be displayed on the console. Okay, the result will be displayed on the console. Suppose you just what we asked earlier, just we want to join these two things, and finally we want to get the user who visited some good page based on the page rank, average page rank and all. Suppose Anil maybe visited some good pages. The result will be displayed on the console if you are using a dump statement. But if you want to store the result back to HDFS once again, okay, after processing, what do you want to do? You want to store this result at HDFS level, okay, at Hadoop level. Like Anil visited some good pages. This is the result, right? So for that, you need to use the store here, okay? Got the difference between store and dump? So if you say dump, what happens? Just the result will be displayed on the console, nothing but on your shell. That's it, where you are executing on the command line. Just you are opening a terminal and running, right? Your big script. So there itself you'll be getting your output. That's it. But if you want to process this data for further analysis, that time you need to store the value. So how you can store the value? Using this store command. So what are the basic structure once again? First of all, the load. So load is simply a file handler. So this load doesn't mean that you're loading the data from local file system to Hadoop. That is the first thing. Okay. Second one is the processing. So where you're giving some big Latin statements like order, join, group, whatever it may be based on your business logic. So finally, store or dump. Okay. Store means result will be stored at the HDFS, and dump means result will be displayed on the console. That's fine. And here we be calling these big scripts are the lazy executors. What do you mean by that lazy execution and all? See, you're writing 10 statements of big Latin or 100 lines or 1000 lines, right? But finally, all these big Latin statements expect you from a store or dump. Nothing but what we call generally as a actionable commands. So you have to give that store or dump. Then only the execution starts place. Okay, so maybe you're giving 10, your script is consisting of 10 statements or maybe 20 statements or 100 or 1000, whatever it may be, the number of big Latin statements. But finally pig always expects you from store or dump statement. So these are the executable commands or triggering commands, what we call. So the moment it receives the store, then it starts executing all those 100 or 200 or 1000 statements one by one, like that way. So nothing but it's in the background, it's running the logical plan, physical plan, an MR plan, and finally you're going to get the result here. That's what it happens. Okay, this is what you mean by that lazy execution and all. So statement by statement, whenever you're giving, that will be not executed. Okay, those statements will not be executed. Is this fine?
Yes.
No. Well, we'll see just a simple thing. Well, I'll come back to this a bit later. Look at this here. Now I'm taking this line here. Right. So what's the problem statement? I just type copying this also. So this is my problem statement here. I'm having a data set called emp.dat. Okay, this is my data set. emp.dat, right? And what I want to do with the help of this data set, I just want to find out the list of employees based on the department. That is my requirement here. Right. So this name, age, salary, and all, what exactly this? This is the schema. Schema of what? This one. So it's having certain fields, right? It's a name is a string literal, and the is an integer, and of course it's having certain fields, department, and of course salary. All right, now fine. So this is the data set, and this is the schema of your data sets. That's fine. Now this is our problem statement. Now what is the first step? Copy from, maybe it's available on your local file system. I'm considering default as a local file system. Copy this employee.data from local file system to HDFS. So this is the first step that you need to do. Okay, next. Here you can see I'm having a grunt, right? So this grunt here is nothing but your pig shell. Okay, after opening a terminal, and if you say pig like this, so it will take to you this grunt shell. Grunt is a pig shell, that's it. Okay, after opening a terminal, if you say pig, what happens? That will take to you a grunt shell. That's fine. What about this? We'll understand this statement. Data is equal to load and emp.dat as something I just given here. What do you mean by that? So data is something like, it's a relation. Okay, it's a user defined relation. It can be anything. Okay, in common programming languages, you can consider this as a variable. Okay, you can consider this as a variable. That's it, not more than that. But generally, we don't call this as a variable. We have given a beautiful name here, relation. Okay, so now what exactly this data? This can be anything apart from the big Latin reserved keywords. You can give anything. You can give Anil, you can give Naresh also. It's not a problem. Got it? So this data is just a variable kind, or we can say this is a relation. So this is a grandshell, what we call. So what exactly the data here? It's a user defined relation, or simply, of course, we don't refer this as a variable, but if you're having any other programming languages idea, certainly you can connect this with a variable. That's fine. Now, here I said data is equal to load, and I have given this slash emp.dat as something. So what do you mean by this slash emp.dat? This means that I just copied this data to HDFS. So my data is already in the HDFS. That's what I exactly performed in my first step, right? Earlier I'm having this data on my local file system. Now what I did, I just copied my data set from local file system to HDFS that already I made here, right? So in the second step, what I'm doing here, this is the second step. So data is equal to load. Of course, data is a, already we discussed, it's a relation, that's fine. So emp.data, here we just giving this location of your HDFS. So data is already there in the HDFS. So this slash indicates, I'm not saying it's a forward slash or backward slash because it confuses. Okay, the guys who came from the Windows, they say it's a backslash, and just we be calling this as a forward slash. So to avoid the confusion, I'm not saying it's a forward or a backward slash, and just I'm referring that as a slash. Here the slash indicates, that your HDFS location. That's it. Okay, so earlier we copied, now it's available in your HDFS. So that's the reason you'll be giving here /emp.dat. Now after that you are writing as right here as something. Name is a string type, age is an integer, department is a string literal, and salary is a float here. So this is something like, you're giving the metadata here. Okay, so this is something like, you just giving all the metadata. Nothing but you're giving all your field names along with the data types. That's it. So here then load, what exactly doing? We said it's a file loader or a file handler, we said. What happens, this data set along with this metadata now will be available in a variable called data. I'm repeating once again. The moment what happens when you say data is equal to load and you just provided the location along with the schema, the data set along with the complete schema now available in this variable called data, or now in this relation called data. Got it? This complete information is now available in this particular variable or relation. So that's what we are saying. So this is the second step. And third step, what you're doing? We are doing some transformations here. Here we are doing some process or transformations. So here we did load. Okay, here we did load. And here we writing some business logic based on the problem statement. So here I said department wise list is equal to group data by department. So what do you mean by that? So this is my problem statement, right? This is my problem statement, right? List all the employees based on the department. So now department wise list is equal to group data by department. That's fine. So what exactly this department wise list? This is one more relation or one more variable. That's it. This is one more variable. You can give anything apart from the pig Latin result keywords. So the department wise list, what happens, is equal to what we said group. This is a relation operator what I given here. Group data. What is data? Data is this one, the previous relation. So group data by department. So you're having name, age, department, salary, and everything, right? So now what you're asking, we just group this previous relation based on the department, and we are asking to store the result in the second relation or the second variable called department wise list. That's it. That is we're trying to do here. Got it? Nice. Please let me know, is this fine or not?
Yes. Yes. Yes.
Fine. So finally what you're doing here really. So finally we said dump department wise list or grunt, whatever it may be, we said here. So even though you're giving data is equal to something, or department wise list is equal to group data by department, nothing will be executed internally. Nothing, but it won't start any physical plan, logical plan, MR plan, nothing will be executed. We said already Pig follows some lazy execution. Okay, so what do you mean by that lazy execution? So it expects some trigger or actionable commands, nothing but a dump or store. So it always expects these commands from you as a final statement. Okay, suppose you said dump department where list, nothing but your previous relation. From where I got this one? I got this from my previous relation here, what I mentioned. So I said dump department wise list. Once the moment I said dump department wise list and hit enter, then what happens? The execution starts place. So what happens here? It goes from here to the upward like this. Okay, here the final statement is dump department wise list. What do you mean by department wise list? The control goes here. So department wise list is equal to group data by department. What do you mean by data? Once again, it's going to here. Okay, data is equal to load something. Oh, this is the one. Then like this, it will start the execution. So in any programming language, you are having some top-down and bottom-up approaches. So PIG here goes with the bottom-up approaches. Nothing but it's taking all the way the last final statement from you, like this, or maybe this. Then it's doing the execution from one by one, one by one, one by one. So if you observe, data is flowing from one statement to the other statement. That's the reason we'll be calling or we'll be treating PIG as a data flow. Latin is a big data flow language or a data flow system that we can consider. From statement to statement, data will flow. Okay. So suppose you said store department wise list. Okay. So no need to give these two statements. Suppose instead of dump, just you have given, just you commented this and you have just given store department wise list into, okay, some location you provided. You can give anything here. Okay. Just this is once again the HDFS location only. You should give input and output always to the HDFS location only. Okay. So this is also related with your HDFS only. So fine. So store department wise list into department. This is the output location what you mentioned. Now once again the control starts from here. So store something this. So what do you mean by this department wise list? The control goes here. So group data by department. So what do you mean by this data? Once again the control goes here. So like the way data, statements will pass on and go one by one, and your data will be flown between this. That's the reason we be calling this as a data flow language. And one more thing, I never worked and I heard about with some of my senior colleagues and all. They said PIG is having some similarities with the language called COBOL. Okay, I think it's a very old one.
Yes, yes.
Uh, COBOL, they worked in mainframes and all IBM.
Yes, yes.
Yes. So there also they used to give in the same manner, like it's English like statements and language statements and all they used to give one by one, and the execution wise it follows some rule, some similarities it's having what they mentioned, but I'm very much not confident about the statement even because I had never worked on COBOL. I don't know whether it's existing at present or not also.
Yeah, it was it. Some people are working on them because one of my brother are currently working on COBOL only.
Really, it's there now. Okay,
Yeah,
great.
is there now? Like it's like he was working on the project from since like 12 years. And
Oh my God. Okay.
uh,
Okay. 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 Great. Right. Right. This is how exactly PIG works for us. Okay. So same statement that if you want to run a a big business logic that you need to supply in MapReduce. And one more thing, if this is available with you, you can give. Okay. I'm telling you here itself. Suppose the metadata is available with you. That's the reason you said as. See, whenever you're writing as a keyword, it means that followed by you're giving the metadata. That's it. Okay. So even this is not available with you, nothing but client is not provided. Simply has given the data. He has not given anything, the data types and all. Sometimes he be just giving that field names, but not giving the data types. Sometimes he's not even giving this also. Still, we can take the data and it can process the data. Okay. So the string, age, or int, whatever it may be. So what PIG will do, it you know follows a concept called byte arrays here. So whenever it's not finding any data type for a particular field, it assigns the things into byte arrays. Okay, so that's really interesting thing. Without that, that's the reason why here we said schemas are optional. If available, just provide in the runtime. If not, please don't worry about that. You can still process the data. Now we'll see one more thing here. Look at this, my second example. So I'm having a CSV file like a movies underscore data, right, which is having almost 50,000 records here, and it just consisting of some details like some field names we can say, or column headers like release year and the rating, runtime, of course the serial number and all, of course. like one the Nightmare Before Christmas, and this is the releasing year, this is the runtime, and this is of course the rating and everything, all details like this you are having. And if you want to work certain for a particular specific requirement, which movie ran for, or which movie has more runtime in a particular year, like we just maybe your proper statement can be anything, but if and all you're having something, you had how you're going to process the data. So first of all, what you had to do, you had to copy this data. Okay, movies dot underscore data dot csv has to be copied to hdfs. That is the first thing you need to do. So once the data is copied to hdfs, then you start writing here. So here, if you look at here, movies is equal to load, and after that I said something, and after that I said something. What is exactly this? So movies is equal to a relation. That's it. Okay, movies is equal to relation or a simply a variable. And this movies underscore data already we copied to hdfs, and here I am just giving the location of the data here. Okay, maybe I just created one folder Naresh in hdfs and I kept the data there. So that time you be giving load, and you be giving the single quotes the location Naresh slash movies underscore data dot csv. That's it. Now here I'm be using the comma separate. Comma is the delimiter or the separator. It's a field separator here in my data. So I can use this particular storage handler using PIG storage. So my data is separated by, or my fields are separated by comma here. I can give the same thing. Suppose this is a TSV file. So just use specify slash t, or you can go without that also. Okay. I'm repeating once again, it's a comma separated. That's the reason we have given here the comma as a delimiter or the separator. But if and only you are having any tab separated data, right? So here you can give slash t, or just you can omit also, because big default data type is a tab separated only. So if and all you're having any tab separated data, no need to give this big storage and all. But still, if you want to give, yeah, you can give that by using slash t here. And if you look at here as, and I said simply ID, name, year, rating, duration, but I have not mentioned any data types here. Just I have given the field names. I just provided the field names, but I have not mentioned the data types. Whether ID is an integer or name is a character, year is a float, like the way I have not given anything here, but still we process this data. Got it? Earlier case, if you observe, it's given everything here. Name is a string literal, is an integer, like the way everything is mentioned here. But here only the partial data is available. Only field names are supplied to you. The data types are not provided. So by default now this will be assigned to byte arrays. Okay, so we'll see that anyway. Practical I'll show you in the hands-on part. Right. Okay, so same thing just I have given as a points in this particular slide. Please go through this particular PPT once it's shared to you.
Yes, sure.
Now coming to accessing Epic, how you can access, you can just submit a script directly, you can run the Epic script, or you can go with a grunt shell, or if and all you want to, you go with some Java related. So there is something like Pig server Java class, like in a JDBC like interface and all. Or if you want to go with any plugin in Eclipse, there is what we call the plugin is available with a name called PigPen. So you can incorporate that and you can write the scripts also. But in our sessions, I will show you these two, how to run the scripts and how to do with the grunting and all. Okay,
Okay.
right. And of course, here, please do remember, Pig needs one more demand to be running on Hadoop or job history server. See, whenever you're running any Pig jobs, job history server is mandatory along with your Hadoop and Earn demands. Okay, Hadoop demands means name node, data node, and secondary name node, and resource manager and node manager, which are related with your Earn. So apart from this, it need a job history server also. It's mandatory to run your Pig jobs, right? So intentionally we don't run the job history server, and you will find out the error what you're getting. Then you will understand why that job history server is really needed for that. Okay, right. Now nothing will has to be there like configured on the cluster level. So data you can keep in the Hadoop, so no need to do any changes. So just at the user machine, just you install Pig here. It's a very simple thing, and you just start working this Pig on your Hadoop cluster. Okay. So yesterday we were talking about N, right? We're talking about multiple engines and all, right? If you remember
Yes.
that, yes, you can run this Pig on MR jobs, or you can run on Tej, or you can run on Slider. It depends. Or you can use this different processing engines can be used. So just you take your pick and you can work on them. So in real time nowadays people working on Tej. It's a good thing. So Hadoop environment only. In terms of storage, they will be using HDFS and ERN will be configured, but processing they are not using MapReduce. It takes a lot of time. So while executing, you feel the difference. It takes a lot of time. So that's the reason people nowadays preferring these as an alternative to run your big jobs or high jobs, whatever it may be. Right. Right. But while running your big script, you doesn't matter. Okay, for you it doesn't matter whether it's they configure MapReduce or they configure Tej or something else. Simply your job is to run your big script. Ultimately, that's the only thing what you can do. We just least bother whether it's running on top of yeah, MapReduce or Tej or something. So of course, whenever you're having some statements like A is equal to lower my file something here, A, B, C, D or the relations here, and here the load is the first statement where you're giving the file location along with the schema here, right? And here we are writing some transformations, and finally you're saying store or dump here. Some statements, some simple statements you are having. So the moment you set store D into something or dump D, then what happens? A big jar will be created. Okay. So generally the jar is created by us, right? Earlier I said mapper, reducer, driver, and we are creating a jar file and we are running the jar file on the data set. So once the moment you said, store D into output or dump D simply, then what happens? A jar will be created. Nothing but some plans, some execution plans will be working in the background. So initially parsing, checking optimizations and executing those plans, you know, submitting this particular job to Hadoop and it's finally monitoring the job progress. Alright. So what happens here? Actually, these are the steps which has to be done manually earlier when you are working with the MapReduce concepts and all, while writing in the Java program. Now, only this much you are doing, the rest of part will be taken care by this Apache PIG engine here really. That's the beauty. That's the reason why here the development time is very less. Just you're writing as a statements like this. But while executing, it takes a lot of time because it has to do these many things to provide the output. The same thing here, the PIG architecture. You can see MR as a background. Why I said MR as a background? Because you can work MR MapReduce or you can work on the Tej or you can work some other independent what we can say ISVs and the software vendors and all. Maybe your enterprise is all the way coming with a new thing. Yeah, there is no problem. You can work AMR as a background or Tej or some independent ISV, what we call independent software vendors. So that is possible here. So, but what is your job is just you provide your big lattice statement. That's it. How they're internally going and working, how they're creating the MapReduce job, it's really nothing to do with us. Just you give your own thing. Your big Latin statement just you provide and rest of the things will be taken care by your big engine. Like it will be working, parsing, semantic checking, nothing but planning, and after that it runs on the user machines or a gateway. This is what exactly happening in the front end and in the back end script execution and which runs on the grid level here. Here you can see here. So this is our script reaching to the parser, doing some logical plan, verifying everything in a semantical verification and all, right? Then it's going with a logical optimization internally. Logical plan will be created, and after that physical plan. Then this to MR translator. Finally, a jar will be created which is running on top of Hadoop. That's what. So these many activities will be carried out by your PIG engine itself. But we are just providing the script, that's it. So finally, once the jar is prepared, it will be running on Hadoop. That's it. Okay, so we don't least bother about this, and we can observe how it happens. Okay, how it's verifying and how it's doing the logical optimizations and all, physical optimizations internally, right? This we can observe as an end user, but we cannot control this flow. It's not in our hand. Got it? There is something like, just a moment. All this anyway. Yes. There is some diagnostic operators, what we call like describe, explain, and illustrate like the way. So this will give these commands just give you some idea how exactly pig is working internally. Once you're giving certain statements and you're trying to run those statements, how exactly the pig internally behaving, that can be fetched with the help of describe, explain, and these other the commands and all. Just we can get an idea. We cannot have any, we are not having anything. We are not having any control here on this. That's what we need to understand here. That's it. That one's just yeah, sorry about that. So like this, you can give some diagnostic operators and you can just get the idea. That's it. How it runs internally, but ultimately we don't have any idea. Or I mean, it's the idea in the sense we cannot optimize our code actually. Now let me go with this. So coming to the hands-on part, of course, in our next session, we'll be covering all these atoms and tuples and bags and maps. We'll be understanding everything, and we'll be working on these data models also, right?
Yes.
And these are the data types and equivalent implementing classes, Java classes and all, like a bag, tuple, and a map and everything. So most of the things will be coming from the Java only, so we don't need to worry about that. But there are some big specific data types also, like bag, tuple, and the map, all these things. Okay, map is also there, but only bag and tuple are specific to pig here. We'll see that,
Yes. Sure.
right? And we'll be working on this, store, dump, filter, join, everything, all commands. We'll be taking some small data sets and we'll be working on this. How it, what happens, what's output, and everything we can discuss. And of course, pig Latin accepts the null value also, what we call the sparse data. For
Yes.
example, certain thing like the Sam age is not known to us really. He has not mentioned that, but still we can process the data. Okay, this is quite against your normal SQL operations. So this has to be there some value. So not null is the default there. You can't have the null data like this, right? So, but still even then we can process the null data also. What we can call is the sparse data. And of course, I will show you all these commands practically, then you'll be understanding more and more.
Okay.
And yes, some additional information also I have given. What about the aliases and all, how to mention that and all. While doing practical, I'll explain what you the case sensitivity and all everything, and we can work on the group, joins, union, and I'll show you some important, commands
Yes.
also.
Sure. Sure.
So that's fine here. So if you have any queries, you can check with me. I'll show you this physical plan and explain plan also practically instead of reading the slides.
Okay.
Right.
Uh, Anil, I have one more. Like, Like one of my friend's fiance is looking for training in the Hadoop with the Spark. So so he asked me like, so you are taking that Spark trainings on the Hadoop Spark training now. So can you ask your trainer to give training session for my fiance like that? So are you available at this time like this time? So
No, this complete Spark level training I'll be providing from next month actually, because already I'm have full with my Hadoop batches itself. Coming to the Spark level, I'll be
uh,
providing from next month
uh
first week.
okay.
So this,
She was here. Can you talk with her? So what she was looking for and everything.
okay. See here, only thing is, if your core Hadoop development in means that's fine. Other than that means, the
Hello.
next month. Yeah, ma'am. Please tell me.
Hi, this is Bharti. So I'm working as a data engineer. I
Hmm.
have worked on SQL and Python before,
Okay,
but
great.
not much into the Hadoop system. But I'm logging into the Hadoop cluster. I write the Spark SQL code because it's similar to the SQL, right?
Right, right.
Want I want deeper, like the map reduce, Scala, and the
Mm,
Spark coding. Right now, I'm getting those kind of works, but I'm until now what I know is I write the Spark SQL, Python, and SQL. These are my three cores. I wanted to get into the Spark code and the Scala and the Hadoop architecture.
mm,
I want you to train me in also like in interview perspective,
right,
like the Hadoop perspective.
right, right.
I used to work as a data analyst actually, data
Mm,
analyst, data. So now it's data engineer. So I want more exposure to the Hadoop system.
fine. So, ma'am, actually, at present, I'm this month just I'm going with this core Hadoop development and all. Like
Mm,
maybe we talking about MapReduce, Big Hive, HBase, Oozie,
mm,
Zookeeper, like that way. It's a
yeah.
of
Mm,
course Hadoop centric and all. But
mm,
from next month, first week onwards, I'll be starting exclusive training on Spark, where we are talking about Spark RDDs, data frames,
mm.
machine learning, and
Okay.
and I will be explaining the Kafka also, the streaming and all, how to control, and the scoop. So the
Mm.
complete Spark perspective training I'll be starting from next month, first week.
Okay.
So
Okay. Next month.
yeah, till that in that
Oh, you're saying October 1st next
yes,
month.
yes.
Oh.
Yes, exactly. It's a,
Mm.
of course, it's a very long tenure because I already having some pre given assignments which are working on some corporate assignments and some other things. So
Okay.
that's the reason it's all the way very long way that I can tell you. But
Yeah.
those are the topics which I'm going to cover, and as a some I'll be giving the complete Hadoop also as a self-paced kind of thing, so that the guys who enrolled for that course they can get that Hadoop also, so that they could.
Okay.
That's what I planned. But
Uh,
that's a complete, I can say that's a complete Spark level training because I'll be working on both the environments because this is a core Hadoop related. Here you'll be getting a basic knowledge of Spark environment, but more knowledge on the Hadoop related in environments and all.
mm.
Okay, but that's a Hadoop, Spark centric. But
Okay. So,
all the major,
what is the major difference? What Naresh is getting now? What is the difference now and the October course?
no, that's what I said. Here, Naresh enrolled for the core Hadoop. Okay,
Okay.
core Hadoop in the sense, just a moment, I'll be taking, yes. So he enrolled for the core Hadoop, so he understanding the Hadoop architecture
Hmm.
in terms of generation 1 and 2. Otherwise,
Okay.
simply I'll show you the 1 second. I'll show you the content, then you'll be understanding very clearly.
Yeah.
Right,
Oh.
ma'am. He is like he is going with these modules.
Okay. Oh,
Okay, so he understanding the architecture level
kernel.
generation 1 and 2 and command line interface, some commands and all, and MapReduce code programming
No,
and pig, hive,
no.
HBase, okay, Woozy
Okay.
and data ingestion tools like Scoop and Flume. And
Hmm.
here in the topic 9, just is getting some idea what you mean by the Kafka, how it will be used, and Spark streaming and
Hmm. Okay.
lib. So he be getting some basic idea and to understand. That's it. Finally, of course, I will be explaining some complete project flow. But the other one, what I'm talking about, the Spark centric training, this will be take the major role. Okay,
Yeah.
after the first module, just understanding what exact the big data problem statement, and we'll be understanding Hadoop, and we'll be working on Spark, and we'll be finding the difference between Hadoop and Spark, when to use and when to go with Hadoop, and to, because there is some lot of misinterpretations and all, like Hadoop is a old, and I mean it's a old outdated, and Spark is a new one. It's not like that. Both are having
Hmm.
their own way of working and all. So we'll be understanding that, and we'll be focusing more on this. So here I'll be explaining the Scala
Okay.
uh, till the Spark. Because complete Scala, you can't get by this module. At
Yeah.
least to understand the Spark and how to implement the Scala you'll be getting. So this completing module 9 will be elaborated into different modules where we'll be working on different use cases.
Okay. So you are right now. You are in module. Right now
What?
you are taking module 4.
Yes, yes, exactly. We are in
Okay.
this module 4. Because
Okay.
like me, so we just completed the 1 and 2, and I just asked, because Naresh is not from the Java background, so I asked you to brush up some Java skills so that he
Hmm.
can understand the map ranges. So remaining just we are going, because there is no way connected with the Java programming and all apart from the UDF concepts. So we'll be
Hmm.
working on Pig and Hive and HBase and all. So before
Sure.
starting this OZ module, I just asked you to brush up this so that I can start and go with the remaining.
Okay. Yeah, sounds good. So we can do the module 9, but I want you to prepare from the interview perspective, like the theoretical, right? So um, uh, I'm attending interview calls also.
Mm-hmm.
So these kind of questions, what is the difference if your data in external Hive table, and what is the difference between external Hive table and internal Hive table,
Right, right.
right? So I want you to prepare me like that as well.
Mm-hmm.
That's more important because simultaneously I'm attending the calls.
Okay, okay.
I'm able to tell the SQL and Python, but coming to the Hadoop systems, at least I should be able to. I'm good at MapReduce or I'm good at the Spark. I want you
Mm-hmm.
to train me, in Spark, which I'm able to tell the theoretical programming.
Mm-hmm. Right. So just think on this, ma'am, like what exactly you're looking, and of course, see, coming to this interview questions and all, that's fine. Like you can prepare. It's not a big deal. But
Hmm.
this is how the things are planned. This is purely a Hadoop centric, core Hadoop centric developer. And
Okay.
yeah, meanwhile, what you can do is you can just refer some blogs and all. You can prepare, or you can go with some other thing. But I'll let you know once I starting complete, stuff on this Spark and Scala. And if you want, like, enroll for the same, you can try with the Hive and HBase, because you're asking something. What is a internal table and external table, when to use and when not to use, so that you'll be getting the questions. Of course, whenever I'm training, I'll be giving some questions and answers also, because we discussed a lot. Even Naresh knows that, right? I
Yes.
explained him very clearly what is a block size, and when to use a bigger block size, when to use a smaller block, and what about the replication, how you're going to configure. So
Exactly.
like this, yes, so these things will be discussed when I'm giving the training part itself. I'm including that. If I'm saying
Yeah, I want
separately,
that
means what
as well.
happens, question and answers kind of thing, it will mess something. But once you got
Yeah,
some exact idea, then you don't forget anything. You can,
correct,
even you
correct. I
can give an
want that
answer.
map reduced, while
Yes.
submitting the Spark job. So how should I increase the number of executors, and how should I increase
Mhm.
the total memory loss? I got like recently the memory
Right.
loss
So
I
for that,
increase
once
the
you're
absolute
having a,
level.
yes, for that, if you're having some knowledge, I mean to say,
Hmm.
actual knowledge, if you're having, instead of preparing a question and answers kind of thing, then you will be able to answer.
Yeah,
Okay.
yeah, yeah.
Because
Hmm.
it's, suppose I'm asking, like, what is your cluster size? If I'm asking the question, at least you
Hmm.
know how many nodes will be there, like, master nodes and, slave demands are,
Data
you can
nodes.
say worker
Yeah.
nodes, yes, data nodes, how you can.
Hmm.
Without that, simply I'm asking what is your cluster size? Simply you're saying 100 or 200. What is that 100 or 200?
Exactly.
So what's the block size that your company is looking? Why that much big block size? Why for the small block size? So that's what I'm saying. See, I'm not giving anything separately, but what I'm trying to do is I'm just incorporating others' questions in this particular training activity so that he feels comfort, like, whenever he's taking interviews like that way.
Got it. Got it. Yeah. Thank you. But something, sooner October, I'll be busy actually. By mid of October, I'm planning to travel to India. So, if something, if it would early, that would be good. So, what are you thinking? Let's say if we start module 9 in depth, how many days it will take?
That is fine, but the problem here is, no, module 9 in depth means already said, right? It almost takes 30 sessions.
Oh, okay.
Almost 40 plus hours.
Oh, okay, okay.
40 plus hours it we're talking in depth, because there you'll be getting some discussion on the Scala. First of all, we'll be understanding Scala, why Scala for Spark. Then we need to understand the Spark architecture, and we need to work on the
Mm,
RDDs and data frames and Spark SQL and
yes.
the machine learning with Spark, and we'll be talking about streaming using Kafka. So a lot of things will
Mm.
happen.
Okay.
So that's the reason. Because already, I'm having a lot of other assignments. That's the reason I'm not finding any time interval to give the particular time. So that's
That's
the reason
fair.
all the way just I postponed to somewhere in the October. So that in the October I'm not giving any training on Hadoop. Simply I'll be giving a training on only this Spark environment, and the guys who enrolled for me to get some idea on Hadoop in-depth knowledge, just I'm providing some other important videos also so that they can get as a self-paced kind of thing here.
Okay, okay.
That's
Yeah.
what I plan.
I'll update you about the October classes. Thank you so
Yeah,
much.
that's
Thanks.
fine. You can't, because for you, maybe it's not feasible even because all the way you like, your profile is in the market and you're working are looking for some opportunities. So I think
Mm.
it's not, you can't wait even that much time, because all the way you were having 1 month. It's a very valuable. So anyway, but I'll just update to Naresh once the training is started. It's you can based on your interest and your time in, you know you can
Sure,
enroll.
sure, sure. Thank you, Anil. Thank you.
Yeah, that's fine. Thank you.
Yeah, no.
Yeah, fine, Naresh. We'll stop the things here.
Okay.
And what we can do is we'll have the session at 9 p.m. 9. Okay, is this possible to have the session at 8 p.m. instead of 9?
Ah, that's fine. No worries.
So, okay, fine. We'll be having a session at 8 p.m. to 10 p.m. IST,
Okay, sure.
right?
Right.
Yeah, thank you.
Thank you.
Thanks for the time.